All right, so today we're on page 742, and it's going to be more tangents and secants. Yesterday we talked about secants and chords that intersect inside of a circle. Today we're going to talk about two situations. One is when a tangent and a chord or array intersect on the circle, and then secondly, it's going to be when they intersect outside of a circle. So theorem 1013 on the bottom of page 742 is what we're going to talk about first. If a secant and a tangent intersect on the circle, then the measure of each angle is 1/2 the intercepted arc. So if we've got a circle here and a tangent, and then a secant, we got point A right here, B, we're going to put point C on the circle. Now we've created two angles. We've created angle 1 right here and angle 2. So if a secant and a tangent intersect on the circle, that's what we've got. We've got an intersection of a secant and a tangent. They intersect at point A. Then the measure of each angle is 1/2 the intercepted arc. All right, angle 1 right here. Here's its intercepted arc. Right there. We're going to say the measure of angle 1 is equal to 1/2 times the measure of arc AB. Angle 1 is equal to half of this intercepted arc. Now, if you see this red arc and half of the red arc gives you angle 1, then angle 2 over here is, you can find it one of two ways. One way would be to subtract angle 1 from 180 because these two are a linear pair. Or we use the same rule. The measure of angle 2 is going to be equal to half of its intercepted arc. And here's its intercepted arc. So the measure of angle 2 is equal to 1/2 times the measure of arc BCA. All right, so let's look at the examples on top of page 743. And we're going to do example 2A. Find each measure. We need the measure of angle QPR. And here's our circle. Our tangent, and then our secant. QPR. Here's Q, P, and R. And you're told that arc RP is 140, looks like 148 degrees. So angle QPR is right here. QPR. The 148 is its intercepted arc. So the measure of angle QPR is equal to 1/2 of 148. So 74 degrees. This angle in here is 74 degrees. So everybody's good with that, right? Let's keep in mind that this circle from P all the way around back to P has to measure 360 degrees, doesn't it? And then if you've got these two angles formed in here, they're a linear pair. So if we want to find angle, let's add point S right here. And if we want to find the measure of angle RPS, the measure of angle RPS would be equal to 180 minus the 74. 180 minus 74 is 106. And then if you needed arc RS, well, if we use the rule or we use the converse of the rule, if the angle equals half the arc, well, doesn't the arc equal twice the angle? All right, so if we need this arc around here, the measure of arc RS, that's going to be equal to 106 times 2. And 106 times 2 is 212. So you can use the rule both ways, okay? You can use the rule both ways. So let's look at example 2B. And we've got a circle. And now here's our secant and tangent. FED. And we're given this 64-degree angle right here. And you're asked to find the measure of arc DEF. So we need arc DEF right here. D through E, stopping at F. Well, let's start with what we know. If we know that this angle is 64 degrees, then arc FD is equal to 64 times 2. And 64 times 2 is 128. So if D to F, arc DF is 128,
Attention for students going on the ACE Marine Science.
If arc DF equals 128 degrees, well then the blue arc would be equal to 360 minus 128. All right, because like I said, we got a circle here. The two arcs have to sum 360. If we know one of them, we can subtract it from 360 and get the other. So 232 degrees. All right, so any questions finding arcs or angle measures using that rule? All right, then the second rule we need to talk about today is on the bottom of page 743, Theorem 1014. And the best way I feel to cover this theorem is with diagrams. All right, I want you to read the theorem. The theorem says if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So here's what they mean by that. Here's the first situation we got. We got a circle. And we've got two secants. They intersect outside the circle at point A. And then we got points B, C, D, and E. Now, before we go any further, do you see the arc from D to E and the arc from B to C? All right, can't you see that DE is bigger than BC? So we're going to refer to DE as the big arc and BC as the little arc. Here's how the rule works. The measure of angle A is equal to 1/2. We take the big arc, measure, we take our DE, subtract the little arc, which is arc BC. The measure of the angle is equal to 1/2 times big arc minus little arc. The second situation that you're going to see, another circle. Now we've got a secant and a tangent. Not two secants. We got a secant and we got a tangent. They intersect outside the circle. The rule is the same, meaning the measure of angle A is equal to 1/2 the measure of arc DC. Here's the big arc. That's arc DC minus the measure of the little arc, which is BC. All right, so we have an intersection outside of a circle. The measure of the angle formed is equal to 1/2 of the big arc minus the little arc. And then the third situation is when two tangents so here we go. Circle. Tangent and another tangent. We've got angle A out here. We've got point B and point C. And we're going to put point D here on the circle. So the measure of angle A is equal to 1/2 the measure of the big arc. Here's the big arc. That's arc BDC. Minus the little arc. Starts at B and goes straight to C. So that's arc BC. All right, so the rule remains the same. It's just a matter of identifying the big arc and the little arc. And obviously, you always want to subtract big arc minus little arc so that you get a positive difference in the two arcs. You don't want a negative difference in the arcs because it'll give you a negative angle measure. All right, so let's do a couple of practice problems and take a look at example 3 on the top of page 744. And let's say we get this picture. Here's a circle. And we get two tangents. Here's angle L. And we're given one arc, 102 degrees. This arc right here is 102. We need the measure of angle L. All right, so if H to K is 102, all right, the sum of the arcs in the circle need to be 360. So if we need the big arc here. So this big arc is going to be equal to 360 minus 102. And the 360 minus 102 is 258. So this big arc is 258. The little arc is 102. So the measure of angle L is equal to 1/2 of 258 minus 102. So take 258 minus the 102 equals and divided by 2. .78 degrees. Let's take a look at example B right there. Now, be careful on that one. We got a circle and a tangent. Secant. We're told that this angle is 56 degrees. And this arc is 95 degrees. We need arc DC. So the measure of DC. All right, we can't just subtract 95 from 360 here because we've got this portion of the circle, right, that needs to be a part of the sum. So we're just going to use the formula. We're going to say that the angle formed outside, that 56, is equal to 1/2 of arc DC minus 95. The angle formed is equal to 1/2 the difference, big arc minus little arc. So if we divide both sides by 1/2, remember dividing by 1/2 doubles, so we get 112 equal to arc DC minus 95, and then add 95 to each side. So our 112 plus 95, our 207 is equal to DC. So the measure of arc DC is 207. If we needed this blue arc, okay, they're not asking for it here, but they could in the practice problems. If we need the blue arc would be 360 minus 95 minus 207. All right, because the three arcs need to sum 360. 360 minus 95 minus 207, 58 degrees. If you needed it. They may or not ask you for it. May or may not ask you for it. All right, so any questions there? When you're working with the tangents, the tangent and secant are two secants that form an angle outside of a circle. The angle measure equals 1/2 the difference, big arc minus little arc. It doesn't matter, you're going to use that formula whether they're asking you for the angle, the little arc, or the big arc. Just substitute into the formula all the given information and solve for the information that they're asking for. All right, so any questions on what we talked about today? All right, so your practice. It's going to start on page 745. Three through 6. Over on the next page, 12 through 16. And 18 through 23. Again, you're doing all the problems. You're checking your odd answers in the back of the book. And we are going to do a study guide tomorrow, quiz on Thursday, and we will be doing EOC practice on Friday this week.